So in this video, we will learn something about which is called as the support vector machine. It's a machine learning algorithm. I will, it's something called as the supervised learning algorithm. We will come back to this topic, like why this algorithm is called a supervised learning algorithm. So before we tell what type of algorithm this is, it is better to know how this algorithm works and how this algorithm deals with the data. Yeah. So how we are going to approach this type of problem is obviously first we will learn something the fundamentals of this type of algorithm, and then how we are going to learn is first we will see how this algorithm works without touching any mathematics, or at least we will not introduce any complex mathematics. At some stage we will try to learn about the jargons of support vector machines. So okay, it is easier to explain how the support vector machines, shortly sometime it's called as SVM, works without touching mathematics. But when we start to explain the mathematics, you should have know the jargons of SVM or the support vector machines. Eventually we will try to introduce some level of mathematics once we know how the support vector machine works, and then we will try to use some approach to implement this algorithm support vector machine just using pen and paper. So which means we are not going to use computer at this moment. So using pen and paper we will try to implement some rules. We can call that as algorithm, and then we will try to, these rules are nothing but the algorithm of the support vector machines. Yeah, so we will try to solve some problem using pen and paper. So that's one way to learn this type of machine learning algorithms. So since we are going to use pen and paper, we are going to deal with a very small data with a smaller dimension, and then we will go to solve some real problem, which is an example problem. So this is, you can take it as an exam type problem. You may see this type of problem that we are going to solve in your final exam. And then finally we will, once we learn everything about support vector machines, it will give you some idea to write about the advantages and the limitations of this type of algorithm. Yeah. And then finally I will explain what type of problems can be solved using SVM. I can tell right now what type of problems can be solved using SVM, but it is better to explain once you know how this algorithm actually works. Yeah. And then we are going to use the same approach when you're going to learn about other machine learning algorithms, something called as principal component analysis, k nearest neighbor algorithm, and deep neural networks. So for this module you are going to learn something of 4 machine learning algorithms. So one is obviously your support vector machine, and then eventually we will learn about PCA, KNN, and DNN. And to learn about machine learning algorithms, it is best to use pen and paper. You solve a problem, and then that's the best way you will know how this algorithm works, yeah, rather than reading it from your PowerPoint. So I'm not going to use any PowerPoint for teaching all these 4 algorithms. So if you want, you can take notes. That's something you can do while watching this video that can help for your final exam. And let's go into the topic. So I'm going to explain the support vector machines without involving any complex mathematics. So let's see how this algorithm works, and then we will go into the jargons of SVM or the support vector machines. So how to think, what is a support vector machine? So let's try to understand this topic. Yeah. So what is a support vector machine? Okay, this, you have to understand few things. Yeah. So don't think too much about the mathematics, just to follow whatever I'm going to explain. Probably this is going to be one of the easiest explanation that you can find about support vector machine. So just imagine, let's say we have a problem, or maybe let's say we went to some lab and we did some experiment, and then we measured something using some analytical tool, or it can be anything that can be easily measured. So usually we call such quantities as measurable quantities. In mathematics we can call them as variables. So let's say we plot variable 1 against variable 2. Simplest example, let's say we have to find the characteristic features of students, yeah, maybe for example. So we can measure then what? We can measure the height of the student, and then the weight of the student to tell something about the student, yeah. So, so height is one variable, weight is one variable. So let's, for the moment, let's see what we are going to, I mean, for the moment, just ignore what we are going to measure. But what you have to understand now is we are measuring two quantities, and we are going to call the first quantity as variable 1 and the second quantity as variable 2. So we are doing this just to explain the support vector machine without using any mathematics. Yeah? So let's say we did some multiple measurements, yeah, or maybe we have so many samples. So for sample 1 you get one height, another weight, and then second sample you get one height, another weight, third sample you get some one variable and second variable, and then for sample 4 we measured something and we got some number for the variable 1 and another number for variable 2. And let's try to plot. Let's say we have some numerical values, and if we plot, we may observe something that may look like this. Yeah, you have something on one side of this graph, and you may have something on the other side of this two-dimensional graph. What it clearly says is when you plot variable 1 versus variable 2, you clearly see some classification. And for the moment, let's assume this group of points that you find on one side of this graph, say let it belongs to group 1. So clearly there is a distance between these two, and there is this set of points which you see here on this side of the plot. Let's call or label them as group 2. So this type of problem is something that can be solved using support vector machine. So clearly you can see some huge differences in it. Here something that lies on one side of the graph and something that lies on the other side of the graph. Yeah, so what is the support vector machine is all about? A support vector machine is something about you have to find a line that separate this category, let's say group 1, from group 2. So that's all. That's the whole game of a support vector machine. So but it's not that easy as I say. So for imagine you can draw a line here, yeah? So that line can separate group 1 from group 2. I can draw a line even here, say in this direction, and that should separate group 1 from group 2. And I can even draw a line here, yeah, somewhere around this side, and that should also separate group 1 from group 2. But that's not our intention is. So we have to find something exactly in the middle of these two, you know, so where the separation between from that line to group 1 and from that line to group 2 should be maximum. You know? So you need to find the game. So the game is this: you have to find that line. You have to find that line, or for the moment we can say the optimum line. So that's not the right word, but I'm going to call it the optimum line. So the game here in support vector machine is to find that optimum line that separates group 1 from group 2, or that separates the two categories. So that line should be in the right position. Yes, so that's, and also in the right direction. Imagine that I can draw one line like that. Yeah, so that also separates group 1 from group 2, but this is not something an ideal line. You know? So I will explain that later, but for the moment you have to keep this in mind. We have to find the optimum location of this line and the direction of this line. So on this line, in the language of support vector machine, it's shortly called as a hyperplane. You know, so I said we are going to see some of the jargons in support vector machine. So hyperplane is one buzzword in SVM. You know, so I will introduce all the jargons in SVM bit by bit, you know, while explaining the things. So the whole game is we have to find the hyperplane. So how to do that? This is not an easy thing to do. You know, so the support vector machine algorithm works in the following way. So what's the first step? So how it works? The first thing is just ignore this line, the best line that separates group 1 from group 2. Now you have to think something else. So you have to draw a line somewhere here. You know, so or this can, for the moment you can call this as a vector. So let's say I can draw a vector somewhere here. So let's draw it. So let's say this is a vector v, for example, for the moment. And then what we will do is, let's say we put a light on the top of this data points, and then exactly perpendicular to this line, and then we put a light here, and then let's try to project each points on this vector. Yeah? So we try to project all the points on this vector. Let's assume this light doesn't introduce any diffraction, so all the points light directly on this line. Yeah? So this point will come here, 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 this point will come here. Yeah? So this is, so you, what you're doing is you're projecting these points onto this line or this vector. Yeah? And then again you have these points here from the group 2. So we try to project all these points onto this vector. Yeah? So if you project, it will come here, it will fall here, it will fall here, this point will fall here, this point will fall somewhere around here, and this point will fall somewhere around here. So once you project these data points onto this vector, what you see immediately that you can observe is there is a clear separation onto these projected data points, isn't it? Yeah. Yeah. So let's say this distance between these two categories, let's call this as D. So let's say this is the maximum and this is the minimum in category 2. Yeah, so let's say this point is something called as a max in group 1, and let this say this point is something called as the minimum in group 1, and these 2 points dictates the separation distance between all the other points in these 2 categories or in these 2 groups. Yeah? So the support vector machine is try to find this vector. This is the first step it does. It tries to do. And imagine that this vector is somewhere, I placed it here, but I can place a better vector somewhere here. Yeah? So let's say I put a vector here. So vector is something that has some direction, isn't it? Yeah? So let's say this is our another vector. I'm going to call this vector as W, and then if you project these data points, use the same principle. We put a light on the top, and then we are going to project. So we have some mathematics to do that. Yeah? So how to project these data points onto something called as a vector W. So let's project for the moment without entering into mathematics. If you project, you get a point here, another point here, another point here, and then another point here, and you project these points here. If you project all these data points, they all get projected on this vector, which we labeled it as W. So this is vector W. Yeah. And again, now you see the distance between this point that belongs to group 1 and the another point which is here that belongs to group 2. Let's say again D. And now if you see, this D must be greater than this D. Yeah, because this vector, if you project all this data point in this vector, the distance between these 2 points that belongs to 2 different categories, yeah, that separates the, and also these 2 points which clearly separate, the distance which clearly characterize the distance between these 2, isn't it? Yeah. So this one to this one. So in this case, this D will be much higher than this D. And why is that? Because this is something we can take it as an optimum vector. Yeah? So, or maybe we can call the correct vector. Correct vector, where if you project the data, so this W is a good notation when we are going to learn about SVM. It's a common notation. Yes. Once you project, the distance between these 2 points, the maximum point in category 1 and the minimum point in category 2 is maximum. Yeah, so the first game that we are going to do in support vector machine is to find the vector where this distance D will be maximum. Yeah, so we will try to find the right vector where we project, and then we will project our data on that vector to ensure that the distance between these 2 categories dictated by these 2 points from each of these categories, should be maximum. Yeah, so at the moment I'm just saying a very casual word like distance between these 2 points, one point from this category, another point from this category, and there is a distance between them that separates these two categories, and we put some label or notation D. Yeah, we are not still introducing the jargons of SVM. So far I introduced only one word which is directly related to support vector machine, that's called the hyperplane. And this vector, I use the notation W. This is something related to the mathematics of the support vector machine. So once you identified this vector, yeah, so what we are going to do is we will project this data point, and then you have to identify the maximum from one of this category and then the minimum from the second group. Yeah, so for example, why do I call this maximum and minimum? So let's say you have this vector, and then let's rotate this vector somewhere around this side. Yeah? If you rotate, it will look like this, isn't it? Yeah? Yeah, and you have some points here. So this belongs to, so these points belongs to group 1, and these points belongs to group 2. So let's put a number starting from 0, 0. So this will be the maximum value in this group, and this value will be the minimum value in this group, isn't it? Yeah. So we have x is equal to 0 through, sorry, y is equal to 0 throughout. So let's say this is say 1, 0, and let's say this may be 3, 0. So this is the minimum in category 2, and this point corresponds to the maximum in group 1 or category 1. So once you identify these 2 points, you measure the distance between these 2 points, let's say D, and then you divide that by 2. So that will give you some middle point here. Yeah. So let's say in this vector, once you manage to identify these 2 points that separates the categories, you find exactly the middle point, which is here, and then you draw a line, yeah, which is exactly perpendicular to that vector. Yeah, so if this is your optimum vector, you draw a line that is perpendicular to that optimum vector. So that will make the hyperplane. Yeah, so that's something we call it as the hyperplane in the language of SVM. And then you draw one more parallel line, a line which is parallel to the hyperplane, but that line should pass us through one of the point in the group 1, which is the maximum point of, say, let's call P max, and then another line that passes through P minimum, which is this point. So this line we should draw parallel to the hyperplane. Yeah, so this distance and this distance should be equal, because this, okay, maybe here. So the distance between this first line and the hyperplane and the distance between the hyperplane and the second line, D1, D2, that should be same. Yeah, so what this line is, so this line is something called as the support vectors. So this dotted line which passes through the P max point, and then the another line that passes through the P minimum that belongs to group 2. So these lines are called as support vectors. Yeah. So we will see the mathematics soon, but shortly I will give you what could be the equation of these 3 lines, which is one is your hyperplane, another one is your support vectors. You have 2 support vectors, and the distance between these 2 support vectors, it's something called as margin. So margin is one of the buzzword in the language of support vector machine. So far I explained what is a hyperplane and what is a margin. We still didn't enter into the complex mathematics involved. And then I said some notation for the vector, let's say W. So W is a vector. Yeah? So how it works. Okay, if you I can introduce some level of mathematics now. So let's say for the if you want to write an equation for this hyperplane, that equation will look like, let me write it here. The equation for the hyperplane will be, so we know the vector is w, so you transpose that vector, and let's say all these points that we are trying to plot on this graph, so one is x1, another one is x2. So you take the vector, transpose the vector, multiply it with x, which is your actual data set that contains two variables. You add a bias, something we call it as a b, and that should be equal to 0. So this is the equation of the hyperplane. This b will be typically the distance between these two support vectors. So b is something related to the margin, and w is your vector, where the distance between these two groups will be maximum after projecting your actual data set onto that vector, which is w. Yeah. And then if you want, we can write an equation of line for these two support vectors, one on this side, another one on this side. So the equation for this side of the plane, so let's say, I mean on this graph, so for this, follow the pen, for this support vector, the equation of line will be wt x plus b. We can prove that this equation holds correct, will be equal to say plus 1, and another side will be w2x plus b will be equal to minus 1. Yeah, so that's almost everything about the support vector machines. Yeah, so what we learned so far is we try to understand how the support vector machine works, yeah, without entering the mathematics. So all we try to do is we plotted variable 1 versus variable 2, and let's say we can clearly see two different categories. Yeah? One is lying on one side of the graph, another one lie on the other side of the graph, and then we try to find a vector. We can draw a vector anywhere in this 2D graph, isn't it? Yeah? So I can draw the vector even here and then try to project, but in that case, after projection, the distance between these 2 points may not be large enough. Yeah, so we need to find the optimum direction of the vector, where the distance between these two categories or these 2 points from each of these categories will be maximum. The distance between p max and the p minimum will be maximum, and it is our job to find the right direction of that particular vector. So keep these things in mind, and then we try to project the data, and then we try to identify these 2 points that separates the two categories, p max and then the p minimum. I will tell right how to label these ones, p max and p minimum, soon when you're going to solve the problem. And these 2 points are nothing but support vectors. So this one point is one support vector and p minimum is another support vector, and then we try to find the middle point, and then we try to draw a line, something we call it as a hyperplane. So this line will be exactly perpendicular to that the optimum vector which we found now, yeah, which we labeled it as w, and the equation of that hyperplane will be this vector. Take the transpose of this vector w, multiply it with your actual data set, which is x1 and x2, plus you add the distance between these two support vectors plus b, that should be equal to 0. So that will be the equation of the hyperplane, and then the equation of this support vectors. Yeah? So which means if your data falls on this side of the hyperplane, that may belong to one category. If your data falls on that side of the support vector, the hyperplane, it may belong to group 1. And you also need to identify the the, the equation of the support, sorry, equation for the support vector. So that will be exactly equal to w to tx plus b equal to -1 for one category that may belongs to this group, and another one will be wtx plus b equal to +1. This is another equation of line for this support vector. Yeah, so we can prove these three equations holds true when you're going to solve a problem. Yeah, so that's everything about support vector machine. Yeah, so even if you use a computer will try to find the right direction of this vector, and then it will try to project the data, and then it will select the vector where the distance between the p max and p minimum after projecting the actual data in that vector is maximum, and then it will try to find the middle point, and then it will try to draw the hyperplane. That line, hyperplane line, will follow this equation, and then computer will try to identify these 2 points and will label them as support vectors, and then this line that represents the support vector which is in parallel to the hyperplane follow this rule. Yeah, wtx plus b equal to -1 for one category, wtx plus b equal to +1 for the second category, and that's all. So what we will do now is we can try to solve a problem. Maybe before that I will shortly explain what is this. Since I said something about w, if you don't have if you don't remember anything from your undergraduate courses where you might have learned something about vectors and maybe matrix multiplication and so on. Yeah, so for support vector machine you should know what is a vector. Yeah, so vector, okay, we will come back to the jargon soon, but since I already introduced one of the mathematical notation w, I will tell how this w looks like in a piece of paper. So let's say we have a variable 1, and let's say we have a variable 2, and then we try to plot some of our data. And whenever I say, the first job is to find the vector w, isn't it? Yeah? And let's say for the moment that vector is given by this number, say w is equal to 1 minus 1. So what does that mean? If you take a transpose of that wt, that will be 1 comma minus 1. So how this vector will look like on this type of graph? So one is on the x side and one other is on the y direction. Yeah, so 1 comma minus 1. So how? So which mean, so let's say 1 and here minus 1. So that's how we label in the graph, isn't it? Yeah? So minus 1, 2, 3 and 4, minus 1, minus 2 and minus 3, and this is 0 comma 0. So this vector, if you want to draw this vector on this graph, so it will be, just plot it, 1 and minus 1. So 1 minus 1, that point will be here, 1 comma minus 1. You just draw a line starting from 0 comma 0. That's your w vector given by 1 and then minus 1. Okay, and if you go back here, w to x plus b equal to 0. So how to do this? So let's say you have a data point, say x11, x21, x12, x13, x22, x23. So this is your x, isn't it? Yeah. So that's your x. x11, 12. Assume these are some numbers. So for the moment I put some notation for convenience. All you need is to take this vector w. If you transpose it, it will be 1 comma minus 1. So you put 1 comma minus 1. All you need is to multiply this vector, transpose of this vector w with your actual data set. If you do that, then all your data will be projected, all the x1 x this one and the x21 x22 x23, all this will be projected. So you have 3 points, no? So it may put one point may be here, another point may be here, another point may be here, you know? So that's how we have to that's how we project the data x onto that vector w. In this case, the vector is given by 1 minus 1, you know? So practically what we are doing is, the first step in support vector machine is you change the two-dimensional problem. So you have variable 1 and variable 2, so that's you have one on the x direction, another on the y direction. It's a two-dimensional problem. By finding the right vector and projecting the data onto that vector, you convert your two-dimensional problem into one-dimensional problem. Yeah, so your two-dimensional problem become one-dimensional problem, you see here. So this is something that's moving in only one direction, isn't it? Yeah, so that's why you convert your two-dimensional problem into one-dimensional problem. That's a very first step in the support vector machines. And then after that, everything is a mathematical game. Yeah, so we have to find p max, p minimum, draw the line, identify the support vectors, and this the line of hyperplane should follow this equation, and the support vector should follow these two equations, wtx plus b equal to -1 and wtx plus b equal to +1. So this should be enough for the moment, and then you will try to learn this algorithm or implement this algorithm by solving a problem, and then we will also do some derivations to calculate. So we already know the equation for two of the support vectors, so we will try to calculate the distance between these two vectors, which is something called as the margin. Yeah, so I will explain you how to do that. So in the next video, we will try to implement this algorithm in a mathematical way. Yeah?